Hello everyone, welcome to today's lesson. So as we are doing application of derivatives, today I'm going to start the last topic from application of derivative, and that is increasing and decreasing function, as you all can see in the screen. So this chapter is included in application of derivatives, as we have some derivative test to decide whether a function is increasing or decreasing. So before we decide what are the conditions for increasing and decreasing function, let us understand the backdrop of increasing and decreasing function. When do you say a function is increasing and when do you say a function is decreasing? For that, let me take equation y equals to x plus 3, number one. Another one, y equals to minus x plus 3. Check these two equations carefully. These are linear equations, linear equations in two variable with power 1. And if I draw them graphically, they will represent a straight line, correct? And if you also know theory from class 10, you would know that this equation is in the form y equals to mx plus c. That is a slope intercept form, isn't it everyone? Slope intercept form. So here the slope is you can say here the slope m is 1 and the y-intercept is 3, whereas on the other side slope is minus 1 and the y-intercept c is 3. So let us draw this functions graphically. So when I draw this graphically, what do I get is slope y-intercept is 3, that means 1, 2 and 3. This is the y-intercept and the slope is 1, and if the slope is 1, the line makes a 45-degree angle with the x-axis, because tan 45 equals to 1, isn't it? So I need to draw a straight line which passes through, okay, let me change this a little, which passes, okay, that would be great, which passes through y equals to 3 here and makes 45-degree line like this. Did you understand? So this is 45-degree. So this is the line that we are talking about in the first case, okay? Whereas the other one, now check this out, the other one, if I draw a graph of this straight line, I will get the slope is again 3, 1, 2 and 3, but the y-intercept is again 3, but the slope is minus 1, and the slope is minus 1 means negative 45-degree. Negative 45-degree means 45-degree on the clockwise side, isn't it? Opposite side. So I'll have to draw something like this. So that would be the line that I'm talking about, because this angle is 45. This would be 180 minus 45, okay? So now these are the two straight lines. Now how to understand increasing and decreasing from function from this straight line is, this side x increases, check this out, x increases. Let me take any 2 point, let's say x1 and let's say x2, correct? Here same thing, I will do the same thing here. Let's say, okay, let me take any 2 point, x1 and x2, and this side x increases, correct? And this side y increases. Or instead of y, I could have written this function as fx equals to x plus 3. That could have can be written like this, the function, okay? This could also be written as fx equals to minus x plus 3. So I can say this is not y, instead I can say this is fx. Now this is fx, and fx increases this side, fx increases as it is written here, correct? So now check properly everyone. Let me show with different color here. As you see, as the value of x increases this side, as the value of x increases, what is happening to the value of fx? Check this. What is happening to the value of fx? The value of fx is also increasing, isn't it everyone? That's why this is called an increasing function. What is it called everyone? Increasing function. Whereas here, when the value of x increases, that the value of x moves towards your right, okay? Then what is happening everyone? Check this out. The value of fx is decreasing, isn't it? Because the second value is here and the first value here is it's decreasing. So this function is known as a decreasing function, correct everyone? So very simple concept. If the value of fx increases as x increases, it is called increasing. If the value of fx decreases as x increases, then it is called a decreasing function, correct? But now let me take this a little further. Let me take another graph. Let's say y equals to sine x instead, okay? What about this? Everyone knows the graph of y equals to sine x, or instead, why should I write like this? Let me write it fx equals to sine x. If I write it like this, then the graph of this function is something like this, isn't it everyone? Yes, okay, sorry, something like this. Let me draw it perfect. Oh my god, yeah, it passes through 0. Something like this. isn't it, everyone? So it's not that perfect, but try to make sense out of it, everyone. So the graph is something like this. Now what happens is, this is 0, this is pi by 2, and this is pi. Okay, now if you ask me what is happening to the function fx equals to sine x here, well, is it increasing or decreasing? Now it depends. Okay, now if you look overall, then sometimes it increases, sometimes it decreases. As you can see here, see, sometimes it increases, sometimes it decreases, the other time again it increases, the other time it decreases, isn't it? So it depends on the interval. That's why now what you have to do here is, instead of directly asking what will happen to the function sin x, you need to ask at what intervals is sin x increasing and decreasing. So here what will I say is, if you ask me what is happening to the function in the interval 0 to pi, if you ask me 0 to pi, pi by 2, that means between here and here, check this out. If you ask me, then I will say that the function is increasing, isn't it, everyone? Decreasing. However, if you ask me what is happening to the function between pi by 2 to pi, here pi by 2 to pi, then I would say that the function is decreasing. Check this out. Got it, everyone? Okay, so for y equals to sin x, we see sometimes it increases, sometimes it decreases. Got it? So you may be asked two type of questions in this chapter, in increasing and decreasing function. You may be asked prove that, or you may say state whether a function is increasing or decreasing in R. Okay, in R, or in certain interval, or in a comma b, in certain interval. They may ask you whether the function is increasing or decreasing in a certain interval. The interval may be already given. Okay, the other case, they may ask you find the interval, the other type of sum in which the function is increasing or decreasing. They may ask you this way also. Okay, so there are basically two types of question that you may get in this chapter. Number one, they may ask you whether the function is increasing or decreasing in a certain interval, which you have to find out, or they may ask you please find the interval. Instead, they may give you a function and ask you to find the interval where the functions are increasing as well as decreasing. Correct? So these two type of questions you may get. Okay, so now this question, whatever examples we had here, was very easy enough, because we could draw the graph of the function, because I knew the graph of y equals to sin x, or fx equals to sin x. I know it's a sinusoidal graph like this. I knew already that the sine graph would be something like a wave like this. That's why I could draw the graph and I can see whether the function is increasing or decreasing. What if, let me rub this, what if you get a function for which you cannot draw a graph? Okay, let me just show it to you. Let's say you got a very complicated function. Let's say fx equals to x plus 1 whole to the power 3, x minus 1 whole to the power 2. If you get this function, now I cannot draw the graph of this function, isn't it, everyone? Yes. So if that is the case, then without drawing the graph, it would be very difficult to state whether the function is increasing or decreasing. Okay, so for that, now what will I do is, I need to figure out some other way to find out whether the function is increasing or decreasing. So for that, I will again take the graph of y equals to sin x. Check this out, everyone, and see what happens to this graph actually. Okay, so I know between 0 to pi by 2, 0 to, let me say this is pi by 2, the function is increasing, isn't it, everyone? Yes, between 0 to pi by 2. Let me draw this graph properly, everyone. Between, okay, that's better. Okay, so I can see between 0 to pi by 2 that the function is increasing, isn't it? Yes. But what is happening is, when the function is increasing, if you see, if I draw tangents at any point at this point, at any point between 0 to pi by 2, if I draw tangents, that I see that the tangents will have a positive, sorry, I can't intersect like that. If I draw at any point, let me draw only two tangents just to show you. If I draw tangents at any point, what I see is the slope of the tangent is positive, isn't it, everyone? Check this out, because this is acute angle, it's positive. Even if I draw it here like this angle will be acute and it will be positive, isn't it? So I see that for an increasing function, the slope of the tangent is positive, and the slope of the tangent at any point in calculus is given by f dash x. That's the derivative, isn't it? F dash x, that's the derivative, dy dx gives us the slope of the tangent at any point. That means the slope here is also positive, the slope here is also positive, and whether you draw slope at any point, it will always be positive. Whereas if you draw slope on the decreasing side, then you see that the slope is negative, isn't it? Check this out, the slope will be negative. Sorry, the slope will be negative like this, because the angle is obtuse here, isn't it? So obtuse angle means negative slope. Tan of obtuse angles are usually negative. Got it? So that's why now what we do is we have a condition. Now from this tangents we can say if f dash x is greater than 0, that means if the slope of the tangent is greater than 0, then we say the function is increasing. And if f dash x is less than 0, what do we say? That the function is decreasing. Got it, everyone? Yes. So that's why for us to decide now if we want to know whether a function is increasing or decreasing without looking at the graph or without drawing the graph, then we need to find the derivative and see whether the derivative of the function at those particular points or at that interval is greater than 0 or less than 0. If it turns out to be greater than 0, then we say that it is an increasing function. If it turns out to be less than 0, then we say that the function is decreasing. Got it? Let us now see another example. Let's say the same example I have here. Okay, now it depends on how the question is being asked as well. Suppose let's say this is 0 and this is pi, and you know right in the middle is pi by 2. Check this out. Now what happens is, if you ask me what will happen to the function y equals to sine x in the closed interval 0 and pi, what will happen to f dash x? You know, if a tangent is parallel to x-axis like this, if the tangent is parallel to x-axis, which it is happening at pi by 2, check this out, at pi by 2 that the tangent is parallel to x-axis, then f dash x will be equals to 0, isn't it, everyone? Because the tangent is parallel to x-axis means dy dx equals to 0, that the slope of x-axis is 0, isn't it? Yes. So if I include pi in this, if I say what is pi by 2, if I include pi by 2, and if the question asks me what will happen to the function between 0 to pi by 2, I know it is increasing between 0 to pi by 2, but the condition for increasing will be f dash x greater than equals to 0, because I know at exactly pi by 2, which is included in this interval, the tangent is parallel to x-axis, and that in that case f dash x will also be equals to 0. So I can say f dash x is greater than equals to 0 in the closed interval 0 to pi. Similarly, if you ask me between pi by 2 to pi closed interval, then in that situation f dash x will be less than or equals to 0. Got it, everyone? Yes. So it depends on how the intervals are given to us and how it is asked as well. Okay, so now having learned all this, let us now further move into finer logic about increasing and decreasing function. Okay, there will be actually 4 situations in this particular chapter. So instead of just understanding increasing and decreasing, we have to understand strictly increasing as well as strictly decreasing as well. Okay, so let me draw 4 graphs here and show you what is the difference between increasing, decreasing, strictly increasing and strictly decreasing. Got it? So this graph, as you can see here, let me show you, is the increasing graph. Okay, I will make you understand this. This is an increasing graph. Okay, increasing. Okay, so similarly, what would be a decreasing graph? Very simple. So a decreasing graph would be like this. This is a decreasing graph. Okay, got it, everyone? Okay, whereas if you see this graph here, then it will be strictly increasing, whereas the fourth one, if you see the graph, suppose let me say like this, then this is strictly decreasing. Got it, everyone? Yes. Okay, now what is the difference? What is happening is actually here, why do I say this increasing and why do I say this strictly increasing is very, very simple. Check this out. What is happening here is, between this interval, let's say a and b, if I take any interval a and b, let's say this is a, this is b, this is a and this is b. if you see that this is A, this is B, if you see that between A and B, what is happening to the graph of the function? These are straight lines actually. You don't need to draw tangents for straight line. The straight line itself decides. It is itself taken as the tangent, okay? So when you see the slope of this line is positive, the slope of this line is also positive. But here in between, this line is parallel to x-axis. That means in increasing function, the slope is greater than 0 sometimes. It can be equals to 0 as well sometimes. That's why for a strict increasing function, the condition becomes f dash x is greater than or equals to 0. Remember that. So greater than equals to 0 would mean increasing at any interval. Let me write it down here. For x belongs to a comma b. So for any interval a comma b, to become increasing, f dash x has to be greater than as well as equals to 0. Whereas for decreasing, it has to be less than as well as equals to 0, as you can see here. So f dash x is less than or equals to 0. That is for decreasing. For any x belongs to a comma b. Remember that between any 2 point a comma b, for it to become only decreasing, it should be less than equals to 0. Whereas for strictly increasing, if you check, okay, there is no such point where the tangent is parallel to x-axis. The tangent will always be greater than 0. The tangent will be always greater than 0. That's why whenever the situation comes strictly decreasing, or whenever the condition strictly decreasing comes, we write f dash x is always greater than 0. There is no way that the function will be equals to, that the derivative will be equals to 0. Because to equals to 0 would mean parallel to x-axis. Is it, everyone? Yes. So if the function is completely increasing itself, that there is no such tangent which is parallel to x-axis, that all the tangents that you have, their slope is always greater than 1, then we say that the function is strictly increasing. But let's say at some point the tangent is parallel to x-axis, the tangents at some point is greater than positive. If the slope of the tangent is positive sometimes, if the slope of the tangent is equals to 0, then we say it is increasing. But if it is never equals to 0 and always greater than 0, then we say it is strictly increasing. So, and final condition, if f dash x is less than 0, then what do we say, everyone? It is strictly decreasing, because in such a case the tangents will always be what, everyone? If I draw tangents here, they will always have a negative slope. So these are the 4 conditions, and I suppose you must have copied this condition. I have posted it below. So I have written clearly here a differentiable function fx in an interval a comma b. Open interval, by the way, is increasing if f dash x is greater than equals to 0, strictly increasing if f dash x is greater than 0, decreasing if f dash x is less than 0 equals to 0, and strictly decreasing if f dash x is less than 0 for any interval a comma b in the open interval. So I hope you've understood the concept of increasing and decreasing function. One more very important thing. Suppose, let's say, I forgot to explain this earlier. Suppose, let's say, if you have a function fx equals to sine x, you know the graph of fx equals to sine x looks like this. Looks like this, isn't it, everyone? Yes, this is 0 and this is pi, whereas in the middle it is pi by 2. Suppose if I ask you what is the nature of this function, or what will happen to this function, state whether the function is increasing or decreasing between 0 to pi. If the question asks, not 0 to pi by 2, had it been 0 to pi by 2, what was it? Everyone knows it. Between 0 to pi by 2, here it is increasing. Everyone knows that. Between pi by 2 to pi, I have already explained this. Between pi by 2 and pi, check this out, let me show you. Between pi by 2 and pi, here, what is it, everyone? It is decreasing, isn't it? But here it is asking directly between 0 to pi. Sorry, it is asking me directly between 0 to pi. That means all this directly between 0 to pi means all this, from 0 to pi here. Okay, what is happening? You see, between 0 to pi, sometime it is increasing, sometime it is decreasing. So when any such situation comes, then we write it is neither increasing nor decreasing. Now you may say, how can that happen, everyone? Because the function is increasing as well as decreasing, actually, isn't it? But what is the question asking me? Try to understand this. They are asking straight whether the function is increasing or decreasing. They are asking either it is increasing or decreasing. They are asking. They are not asking us whether both will also happen. The condition was, is it increasing or decreasing? There was only 2 options. Is it increasing? No. Is it decreasing? No. So that's why we write it is neither increasing nor decreasing between 0 to pi, because between 0 to pi, neither it goes up and up and up, nor it goes down and down and down. It actually goes up as well as down. That's why we can neither say it keeps on increasing, we neither say it keeps on decreasing. Okay, so this is the condition of neither this is the situation where we have neither increasing nor decreasing. Okay, so please understand this theory properly. We will do some sums based on increasing and decreasing functions. Okay, here we have some sums based on increasing and decreasing functions. The first one, prove that the function fx equals to x cubed minus 3x squared plus 3x minus 100 is increasing in r would mean here real numbers. Okay, so if this function is increasing in whole real numbers, I need to basically prove that its derivative is always greater than 0. Got it? Because if its derivative f dash x will always be greater than 0, that would mean that the function is always increasing, isn't it? Because for an increasing function, its derivative will be greater than 0, because derivative greater than 0 means its tangent is positive. Got it? Okay, so let's start. So f dash x equals to, okay, let me just start right from the beginning. Given fx equals to x cubed minus 3x squared plus 3x minus 100. Therefore, what will be f dash x? F dash x equals to x 3x square. I need to differentiate this, minus 6x plus 3. If I take that, it will become 3 common, x square minus 2x plus 1. Check this bracket properly. That can be turned into a perfect square. That's x minus 1 whole square, isn't it, everyone? Now see this function properly. What do you think? X square minus 1, we know now 3x square minus x minus 1 whole square is greater than 0 always, isn't it, everyone? Yes. How? Which is because whatever value of x I put it here, if I put the value of x here as a negative or positive, because of the presence of square, this will always be positive, and this 3 is always positive. So that's why what can we say, everyone? Thus fx is always increasing in r. Check this out again. I'll repeat. Why is it always increasing in r? Because this function turns out to be a perfect square, and perfect square is always positive. Whatever number you put in this x, whether x minus 1 becomes positive or negative, because there is a square, and the square of a negative number is also positive, square of a positive number is also positive. So this function will always become positive. And if this function always becomes positive, if f dash x always becomes positive, then what can we say? That the function is always increasing in r. A very simple easy example. Got it? Let's go to the next one. Okay, so this will be the last one for today. I'll solve further more sums in next class. So I will end this today's class with this sum. Check this out. Find the intervals. Now this is the other type. We have to find intervals here in which the following function fx equals to 2x cubed plus 9x squared plus 12x plus 2 is increasing or decreasing. Now we are not aware where it is increasing or where it is decreasing. Our work is to find out those intervals. Got it? So let's start. I'll start by again, given fx equals to 2x cubed minus 9x squared plus 12x plus 2. I know the derivative tests, so I need to find the first order derivative. F dash x will be 6x square, isn't it, everyone, minus 18x plus 12. Got it? Now I can take out 6 common here, x square minus 3x plus 2, isn't it? Okay, now what I need to do is I need to break this function. I need to prove whether this I need to find the intervals where this function is increasing or decreasing. For that, what I'll do is I'll compare this first order derivative with 0. Let f dash x equals to 0. Let me find those points where f dash x will be exactly 0. If f dash x equals to 0, the tangents are parallel to the x-axis. Isn't it, everyone? That is, each and every time the tangent is touching the x-axis or parallel to x-axis. Got it? Okay, so that gives me now 6x square minus 3x plus 2 equals to 0. That gives me x square minus 3x plus 2 equals to 0, because the 6 goes below 0 and vanishes. X square minus, let's break the middle term, 2 plus 1, x plus 2 equals to 0. That gives me x square minus 2x minus x plus 2 equals to 0. X common, x minus 2 minus 1, x minus 2 equals to 0. So that gives me x equals to x minus 1 and x minus 2, 2 factors equals to 0. That is x equals to 1 or 2. Got it? So we got 2 checkpoints. So there are 2 points between in the whole real numbers where the tangents are parallel to x-axis. That's 1 and 2. Okay, so if that is the case, then what I'm going to do is to prove this function, we will graph this quadratic equation. Okay, we will find out where is the quadratic equation positive or negative. We'll try to find the nature of roots of this quadratic equation. Got it? So what I'll do is, let me draw a line graph like this. I know this function as a turning point of 1 and 2, isn't it? Okay, so we will check the value of this function f dash x at each of these intervals, because there are only two such points where this function is exactly equals to 0. F dash x is 0 at x equals to 1 and x equals to 0. Because when I compared, again I'll repeat, when I compared f dash x with 0, then I found out the value of x is 1 and 2. That means exactly at 1 and 2 f dash x equals to 0. Beyond that we have no idea. Okay, so the whole real number is in our hand. This is the whole real number, as you can see. This is the whole real number. Now what I'll do is I will separate these real numbers into 3 intervals, because beyond, on the left of 1, between 1 and 2, and on the right of 2. Got it? Now I need to find the sign of this f dash x. If I am able to find the sign of f dash x, if f dash x is positive, negative, positive, something like this. Okay, we have done this in class 11 as well. If I find the sign of f dash x at these intervals, then wherever it is positive, it is increasing. Wherever it is negative, it is decreasing. Isn't it, everyone? Because if I find out f dash x is greater than 0, that is positive, then it is increasing. If I find out f dash x is less than 0, then it is decreasing. Let's check what will happen on the left of 1. Okay, let's put the value on the left of 1. If I put the value and check this particular function, check this out, put the value on the left of 1. Left of 1 would mean 0. When I put the value 0, then I find out 0 minus 0 plus 2, that will be positive, isn't it? Yes, check it out one more time, everyone. If I put the value 0 in this f dash x, in this function, by the way, if I put 0 here, then what will happen? We will get the answer 6 to 12. That means positive. Okay, put the value between 1 and 2. Between 1 and 2, let me put 1.5. okay, put the value 1.5. check this out properly. Okay, you might need a calculator for this. Put 1.5. so what I'll get is 6. I'll show you here. And 1.5 whole square minus 3 into 1.5 plus 2. Alright, so 6 into 1.5 whole square is 2.25 minus 5, and then 4.5 plus 2. And that gives me 6, and if you add these two, you'll get 4.25 minus 4.5, and 4.25 minus 4.5 is definitely negative, and negative into 6 will be negative. Got it? So here I'm getting negative. Did you understand, everyone? And finally check beyond 2. Let me put 3. So it will be 6 into 9 minus 9 plus 2. So 9 and 9 gets cancelled, and I'm getting positive. So here I got the solution. So let me write it down here in detail. Okay, let me write down here. So I will write down here and this at minus infinity to 1, from minus infinity to 1, f dash x is greater than 0. At 1 to 2, f dash x is less than 0, and at 2 and beyond, f dash x is again greater than 0. Did you understand? Check this out one more time. This is what my conclusion is, because I checked with the point, isn't it? I took a test point and put the values here, okay, in the following function f dash x, and I found here it is positive, here it's negative, and here it is again positive. So I'll write at minus infinity to 1, it's positive, negative, and positive. So here I have the conclusion. So what do I write? Let me write it down at the side here with a different color, black. So I'll write thus the function is, let me write it down, increasing at minus infinity to 1 union 2 to infinity. Isn't it, everyone? Two intervals are there where it is increasing. These are the intervals where it is increasing, this one as well as this one. That's why I write it between minus infinity to 1 and union 2 comma infinity is increasing, and decreasing at 1 to 2. So that is the interval where the function is decreasing. Okay, so please try to understand this sum properly. So if you have to find intervals whether where the function is increasing or decreasing, what are the steps? First, find the first order derivative. Second, compare the first order derivative with 0, get those test points or the turning points as I've got here, 1 and 2. After that, separate the whole real number based on those turning points. So since I got 2 turning points, so I had 3 intervals. If you get 3 turning points, you'll get 4 intervals. If you get 4 turning points, you'll get 5 intervals. Got it? So because of these turning points, my whole interval got separated into 1 part, 2 part and 3 part here, 3 parts. And then take each point from those 3 intervals and test on f dash x, and find the sign of f dash x on each of those intervals. If the sign turns out to be positive, it is increasing. If the sign turns out to be negative, it is decreasing. Okay, so we will try to solve more sums in the next class. I hope you have understood this the theory about increasing and decreasing functions and the 2 sums. So please copy these sums as well as the theory that is attached below as a PDF file.